Today's lesson, we continue to look at expanding, but some of our bigger questions. And there was a gentleman in history who had last name of Pascal, and he developed this triangle, Pascal's triangle. And what Pascal's triangle helped us to do was able to expand questions that had a large exponent. So let me show you here off to the side. We know how to do x plus 2 squared. We looked at that last year and this year. But what if our question came x plus 2 to the power of 5? That means we would have to write this base 5 times and then continue to expand and gather like terms. That would be a lot of work for us. So over time, some patterns were recognized. Let's just remove the scrap work here. Some patterns were recognized so that we didn't have to do all of the math. What I'd like you to do is take some time to expand A, B, C, and D in your notes, doing it the way we know how, the long way, and then look to see if there is a pattern. So pause the video, attempt those questions, and then start to play it again when you're done. Now, if you have expanded properly, here are your solutions. This is what it'll look like. You've written all of your binomials down as many times as the exponent said, and then you continued to expand and gather like terms until you had your final answer. So in our term here, so on each term, let's look at the exponent. There's an exponent of 1 here that we don't show, an exponent of 1 on the B, an exponent of 1 on the A. Here we have an exponent of 2 on the A. There's an exponent of 1 on that A, and then there's 0 A's there. If we look at our A's in the next example, our exponent starts at 3, 2, 1, and then 0. There's no A's. So hopefully you might be starting to see a pattern. There was also an exponent of 3 there. So on the first term here, we have an exponent of 4, 3, 2, 1, and then 0. So our first term, the exponents on it start at the same number that you see outside the bracket, and then it continues to count down. It goes in descending order. Now if we look at our second term, our B term, our exponent here, there's no B there, and there's 1 here. Again, we start here, there's no B here. Note that 0 B's, 1 B, and then 2. In our example here where the exponent has a 3, there's no B's in the front, there's 1 there, 2 there, and 3. No B's here, 1, 2, 3, 4. 4 coordinating again with the exponent that you see up top. So what you realize with your A term, your exponents descend from the exponent down to 0. And with your second term, your B term, they ascend. So they start at 0 and then they increase along the way. Our last thing, we'll show one other color here. Here, when we have an exponent of 1, that coordinates with our row 1 in our Pascal's triangle. These numbers here tell us our coefficients that are in front. You can see there's a 1 in front of the A and a 1 in front of the B. So here we have an exponent of 2. So exponent of 2, so now we're looking at our row 2 all the way across. Our coefficients should be 1, 2, and 1. This was the pattern that was learned. There's a 1 there, a 2, and a 1. So for our exponent of a 3, now look at the row 3, there's a 1, 3, 3, 1. So rather than having to do all of the work, if we learn Pascal's triangle, we can use our exponents decreasing for the first term, increasing for the second term, and then put our coefficients in front. So last one, row 4 here, our coefficients are 1, 4, 6, 4, and 1. You can see 1, 4, 6, 4, and 1. Okay? So let's look at the question that it says here. Each row is developed from the previous row. So if we need to learn how to make Pascal's triangle, clean it up here. If we make the Pascal's triangle, let's look at row 0. Row 0 just has a value of 1. The second row, or row 1, we have to always keep in mind it does start from 0, which is sometimes hard for students to get used to. Okay, the second row, which we call row 1, is 1, 1. Next row, row 2, 1, 2, 1. So what we might start to see is 1s are always going to be on the outside. That's part of the pattern in building it. Row 3 here, 1, 3, 3, 1. Our 1s are on the outside, but we can start to see that the 3 came from adding 1 plus 2. 2 plus 1. And then we keep the 1s on the outside. So if we continue with that pattern, let's see where that 4 came from. 1 plus 3, 3 plus 3, and 3 plus 1. Continuing on, 1 plus 4, 6 plus 4, 6 plus 4, and 4 plus 1. So if we wanted to make row 7, we always add the 1, and then we add our 2 terms together. 6 plus 1 is 7. 6 plus 15 is 21. 15 plus 20 is 35. Squeeze that in. 20 plus 15 is 35. 21, 7, and always end with a 1. So we can continue to build our triangle depending on how many exponents there are on the binomial. So to help us make better sense of this, let's look at the example of 2x plus 3 to the power of 4. So the first thing that we need to know is that this is the 4th row of Pascal's triangle. So let's just scroll up so we can see it. I'm going to clean up the triangle that we've already used so we can use it again. Good enough there. All right, so we're going to use row 4 because that is the exponent. And then we can start to actually solve 2x plus 3 without having to write it, plus 3 to the power of 4 without writing it, without having to write it out 4 times. So now we can use Pascal's triangle to build it. And we remember that our first term will be to the power of 4 because that's the exponent out in front. Now we'll show it for today, but we normally don't. Our second term is 3, and we always start our second term counting from 0 and counting up. So again, we have our first term descending, so that will be to the power of 3, and our second term will be increasing, 3 to the power of 1. Now we can't forget our coefficients from row 4, which I have highlighted above. So our coefficients here are 1, 4, and we will multiply those in afterwards, and then 6. So we continue in descending order, squared, 3 squared. A good trick to realize to be sure you're not making any small mistakes, if you add your exponents together, they will always equal your original exponent of 4. So 2 plus 2 is 4, so I know I'm on the right track. My next coefficient from the triangle says that I write the 4, and I continue in descending order. So that's now to the power of 1, and then 3 cubed. Last one, a coefficient of 1, 2x to the power of 0. And we don't normally write that because we know anything to the power of 0 equals 1. So we don't have the need to do that anymore. 3 to the power of 4. All right, so now we continue on to our next line. We know that 2 to the power of 4 is 16, and then x to the power of 4. It's really, really important that you remember that 4 is on the 2 and on the x. 3 to the power of anything just equals 1, so that disappears. So now we have 4 times 2 to the power of 3 equals 8, x cubed. 3 to the power of 1 equals 3. Eventually, we're going to get to multiply all of those coefficients together in the last step. 6 times 4, x squared, times 9, plus 4, times 2x, times 27. plus 81. Our last line here is just our final multiplication. So we have 16x to the power of 4. Now we're going to multiply the 4 times the 8 times the 3. It's multiplication all within that term. So 4 times 8 times 3 is 96. Then we still have our x cubed. 6 times 4 times 9 is 216 x squared. Multiply all of those out, it gives us 216 as well. X plus 81. And we check to see our exponents are going 4, 3, 2, 1. And our numbers are there, and we are all done that question. We have 3 examples here that are good ones to try to be sure we fully understand. I'm going to do question B for you. And at the end of the video, I would like you to do question A and C on your own and bring them into class tomorrow. So the first thing that I'm going to do is I'm going to write down my third row of Pascal's triangle. 1, 3, 3, 1. That's row 3, and the reason I'm doing that is because of the exponent 3. So now I'm actually going to start to write it all out. My first term is 1/2 x, and then I cube that. My second term is to the power of 0, so I don't need to show it. From Pascal's triangle, my coefficient is 3. Then the 1/2 in descending order, so that's going down to 2. And my second term of 3/4 is to the power of 1. Again, Pascal's triangle has the 3 as the coefficient, 1/2 x to the power of 1, which we don't need to show anymore, and 3/4 increasing squared. And our very last term, a coefficient of 1, 1/2 to the power of 0, we don't need to show, and we have 3/4 to the power of 3. Just going to clean up this here so it looks more like a 1. Got a little messy there. All right, let's finish off this question. So when you have an exponent outside of the fraction, remembering it's on the numerator and on the denominator and on the variable. So I'll show the first one long, which you don't need to, and then we'll start to show our work properly. So what I have is 1 to the power of 3, 2 to the power of 3, and the x to the power of 3. So now I have 3 times 1/4 x squared times 3/4. So I'll multiply that 3 in actually right now. 3 times 1 is 3 over 2 x, and I have to square the 3, which is 9, and square the 4, which is 16. 3 cubed is 27, and 4 cubed is 64. So what we have is x cubed over 8. 2 cubed equals 8. Now I can just multiply all of my numerators by each other. So I can show you here, 3 times 1 times 3, which equals 9x squared. And then my denominators, again, there's technically a 1 there. 1 times 4 times 4 is equal to 16. 3 times 9 is 27x over 32 plus 27 over 64. Now if there was any reducing that you could do here, you would, but all of our terms are already in lowest terms, so we are done this question. Again, I just did B for you. Please come to class with A and C completed.